Black holes. Don't let the name fool you. A black hole is anything but nothing. Rather, it's a great amount of matter packed into a very small area. Think of a star 10 times more massive than the Sun, squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape from it. The idea of an object in space so massive and dense that light could not escape it has been around for centuries. Most famously, black holes were predicted by Einstein's theory of general relativity, which showed that when a massive star dies, it leaves behind a small, dense remnant core. If the core's mass is more than about 3 times the mass of the Sun, the equation showed the force of gravity overwhelms all other forces and produces a black hole. Once a star's end is a black hole's beginning. Most black holes form from the remnants of a large star that dies in a supernova explosion. If the total mass of a star is large enough, it can be proven, theoretically, that no force can keep the star from collapsing under the influence of gravity. However, as the star collapses, something strange happens. As the surface of the star nears an imaginary surface called the event horizon, time on the star slows relatively to the time kept by observers far away. When the surface reaches the event horizon, time stands still, and the star can collapse. It's a frozen, collapsing object. According to Einstein's theory of general relativity, massive objects create distortions in space and time. In a black hole, these distortions so strong that time behaves in unexpected ways. So what happens when I drop a clock into a black hole? Imagine that we are on a spaceship near a black hole. We drop a clock into the black hole and compare its time to that of our onboard clock. The falling clock runs progressively slower. It never crosses the event horizon, but stays frozen there in space and time. The falling clock also becomes continuously redder, since its light loses energy as it escapes from the black hole's vicinity. By contrast, if we were falling with the clock, time will appear normal. We will see no slowdown as we approach the event horizon. We will cross the event horizon without any perceptible change, and our color will not appear to change. This is the principle of relativity. Things can appear different depending on whether we are moving or standing still. But what will happen to your body? What happens when I fall into a black hole? Let's assume you start outside of the event horizon of the black hole. As you look toward it, you see a circle of perfect darkness. Around the black hole, you see the familiar stars of the night sky, but their pattern is strangely distorted. As the light from distant stars gets bent by the black hole's gravity, as you fall toward the black hole, you move faster and faster, accelerated by its gravity. You feel a strong gravitational pull than your head because they are closer to the black hole. As a result, your body is stretched apart. For small black holes, this stretching is so strong that your body is completely torn apart before you reach the event horizon. But if you fall into a supermassive black hole, your body remains intact, even as you cross the event horizon. But soon thereafter, you reach a central singularity, where you are crushed into a single point of infinite density. You have become one with the black hole. Unfortunately, you're unable to write about your experience, and no one will know. But Einstein's theory of general relativity allows us unusual characteristics for black holes. For example, the central singularity might form a bridge to another universe. This is similar to a so-called wormhole. Bridges and wormholes might allow travel to another universe or even time travel, but without observational and experimental data. This is mostly speculation. We do not know if bridges or wormholes exist in the universe or could have even formed in principle. We humans know nothing about this phenomena, but someday we will travel into a deep space to solve all these mysteries.